Good afternoon. Yeah, I think that I forgot this Jupyter notebook. So before I proceed further, let's take a look at some examples about the hypothesis test and the confidence interval. So again, we start with our familiar NumPy. We import NumPy, then we import another SciPy statistic package, then the matplot for plotting purpose. So we start with generate two secret number, because as I think that I mentioned early during the class, there's a few bitwise operations. We do not need to worry about during this class, but here we make use one of these XOR signs, since we don't know what we haven't taught what that is function about. So we get two secret numbers. Yeah, we don't exactly know what number these two are. But then we're using these two secret number as a mean and standard deviation to generate 100 samples. Because you can see random norm. So basically we generate some kind of Gaussian samples using the first one will be the mean, the second one will be the standard deviation. Then we say we like to have 100 of them. So this will be the histogram. So we plot out the histogram. Okay. So from this histogram, we can roughly guess probably the actual mean is something around 55, 56, something like that. Yeah. So, but now we want to do the following. We want to make a hypothesis test to say whether the mean is 50 or not. So we make our non-hypothesis to say the true mean of the sample distribution is 50. 50 is here, so it looks like more or less our hypothesis is true. Yeah. So, but at the moment we don't know, so we want to find out. So if this hypothesis, the non-hypothesis, we can't accept that or we reject it, then we will fall back to our alternative hypothesis to say the mean of the sample distribution is not 50. Okay. So now we will show how to do this in Python. We have seen a lot of those during the lecture to say what's the intuition, what is the mathematical, the procedure behind. So now let's see how we write that in Python code. So first we call numpy.mean to generate the mean. Okay, because this sample distribution, you can think them is an array or is a list contains of 100 numbers. So you just call np.mean, you will get the average. And you call the length, okay, the ALEN, you will get the size, sample size, right? This is pretty standard. You will use this for million times. And then we will try to get a standard deviation because in order to do this hypothesis test, right, you need to estimate the standard deviation from your sample, right? So you need the mean, you need a standard deviation. So now we will try to say, okay, we will do this SDT standard deviation, and this is a degree of freedom. Remember, we have formula during the lecture. We have 1 over n minus 1, right? So by default, if you don't specify this, it will use a formula 1 over n. So, but we want to introduce the 1 as a using our unbiased estimation rules. So we are using 1 over 1 minus 1 formula to do the standard deviation. Then remember, we are computing the standard error here. So we need to divide by the square root of your sample size, the square root n. Remember the formula, okay? So now after you get this standard error, we are ready to compute our z-score, right? I mentioned the reason to compute a z-score is because we want to shift it to this normalized to the standard norm distribution. So we were using the mean, take away the 50, and divide by the standard error. Remember the z-score formula. So then we were ready to compute the p-value. The p-value, I think that we have seen this once, this exact statement in the lecture, right? So we will do this negative ABS. Then recall why we do the negative ABS, because we have symmetric two side, and then we go to the negative side, and we want to compute the CDF of that. Then because you have symmetric two regions, so you using 2 times that, you get p-value. All right. So the next is just to do some plotting. You do the NP arrange. This NP arrange is try to create, you give the starting point and end point, you try to create some kind of evenly spaced points. So you basically you generate between -1, -6 and +6, you want to using a step size 0.01 to generate many equally spaced points as your axis, as your x-axis, okay? And then you do this normal PDF. Oh, sorry. You do this normal PDF. You try to generate what is the corresponding density value of each point, right? Because now we want to, the reason we want to plot is we want to plot this curve. So you need to have the x-axis value. You need to have the y-axis value. The y-axis value is the density value here. So you are generating using this this formula, okay? And then we want to plot our z-score, which is, and we put a marker to say, okay, this red one is z-score. So from this picture, immediately we can see this actually, the current null hypothesis looks like not in a very good shape. It's like very into the tail region. So far, is any questions? Are we comfortable with this? How we write this hypothesis test using the Python? Any questions about this so far? Okay. So then we will say, okay, the p-value for this hypothesis is this, and this is some kind of string formatting. I think that I mentioned this probably during some early lecture. And then this will be the output. You can see the p-value is this tiny. So this is some kind of will indicate actually it's in a rejection region. Of course, you need to define alpha, define your significance level, but usually we put yeah, this is a too tiny value, so we will reject it. So this will give the indication to say, okay, your non-hypothesis will be rejected. So that means your population mean is not 50, right? This is pretty much our guess, right? Because we are thinking the mean probably is around 55, because when you say 50 is a little bit off. So now the next question is, what can we find? Since we know now your 50 is not the population mean, and can we find a 90% of confidence interval for the true mean, right? So you give me 50, can I know what will be the range I need to specify in order to have the 90% of the chance to have the true mean to fall into my region, right? So this is a next task we are going to do. So first, we need to compute the z-score. So this is essentially to say, if I using my given mean, the sample mean as one side, okay, I need to construct a Gaussian distribution. So basically, we are looking for the center. To make sure I find the right center, my sample mean will have a z-score which happen to make this center region to be 90%. Yeah. Okay. So if my words sounds too complicated, go back to check the slides. So I think that we put a lot of words about these sections. To do that, very simple, right? Since now we want the center region to be 90, and we know the true symmetric tail region will be 1 minus 90. To get the positive small region, we just divide by 2. Then we use 1 minus that to get the CDF to the left. So I hope you have the picture in your mind. So that will be your Z-score. All right. Sorry, you will compute the PPF. The PPF is try to look for the axis, point match to a CDF, because this 1 minus this will be the CDF, be the whole region up to this score point. Okay, so now we will look back, like a kind of reverse look. Look, what will be the Z-score to make sure this region to be this value. Okay, so after we get the Z-score, then you just remember, you just plug in into the formula we get. So you were using your sample mean plus and minus the Z-score multiply your standard error, right? So this is a recall. During the lecture, we have this. I told you we have studied so much, but actually what you care is the final equation. You just plug in, you will get your boundary, max and min. So then we can very happily to announce the 90% confidence interval will between 53 to 56. Okay, so basically you get a batch of samples, you do a measure to say, okay, this is 50, then you try to estimate what will be the standard deviation of this batch. Then based on that, you can roughly to say, to find a interval, then to claim this interval will have 90% of chance to hold the true population mean. Okay. Any questions? Are we okay with this part? Then at the end, we reveal the true mean and true standard deviation. These two secret number, we get 55 and 10. Okay, so if you plugging back, you can see, okay, actually the true mean is within this range. So within this 53 to 56. So you can see those simple techniques actually is very useful. When you have real world, some data, some numbers, you want to draw some conclusion, those provide you some kind of fundamental tools to do that. All right, any questions about distributed notebook? All right, so glad we are fine with this. So let me move to the, let me finish the file IO, and then today we will move to another topic called regular expression. I think that we stop at these slides. Okay, so to better appreciate this slide, I think that let's start from the slides, one slide early. As I mentioned, when we open a file, we need to remember to close it, because in order to release, just think about, I mean, different operating system probably implement those differently, but in general, when you call open a file, you need to allocate some memory in your right. Just think about when you try to, let's say, copy something from your hard disk. Sorry, to start working, what you do? You in C or in what you in those low-level language, you will call a manlog or something to allocate a bunch of memory, right? In order to prepare to receive the data. So if you, the most natural place is when you open, you do the allocate memory, then you close your file, you release the memory, right? So if you don't close properly, probably you will have memory leak. You will have a chunk of memories allocate there, but you forgot to flash it. So which is reason you need to have open and close. But when you open the file, you meet a lot of problems when you write, or sometimes you have exceptions. Maybe when you open a file, you already allocate memory, but then you can't find that particular file or something. I don't know, for all kinds of reasons. Okay. Then your program terminate unexpectedly, then you haven't do the close. So in order to avoid that, we usually do this try and finally. So basically you try something, even you have problems, then you still will execute the f.close. Okay. And another more neat way to do this is use the with. So you can say with open some file, some mode, then sf. Okay, then this f will be your file handle. Then you can say f.write, f.write, write one line, write another line. So you can see we do not have close here, because when you use with as f, with open as f, it will implicitly to handle this file close the issue for you. Yeah. So this is probably a more simplified way to avoid this accidentally how to say exception. Okay. And I think that I have also mentioned there's a couple of file mode. You have W, you have R, you have A. I think just try to refresh your memory. The W is to say you open the file for write, but you will overwrite whatever inside your file. Okay. So basically you will overwrite. All right. When you do the A, you still open the file in a written mode, but whatever you're writing will be appended to the end. Okay. So that is the main difference between W and A, but both are written, will open the file for writing, and then R will be open the file for reading. Okay. So by default, I believe when you open the file without specifying anything, you will be open in the read mode. So by the way, this is a f.write. This is how do you put a line into the file. Okay. And you can, again, of course, you can open the file in a read mode by specify R, or do not specify anything. Then you can say f.read 4. What does that mean? That will read the first 4 characters. Okay. By the way, when you do not specify anything, you are assuming you open the file in the text mode. Okay, we didn't mention this, so probably you don't need to really know this, but just for your information, you can open your file in a text mode or open file in a binary mode. Like for example, a video, right? There's no text inside. You have to open the file in a binary. But in general, when we play with those data science, we usually assume those data contains numbers, or those probably we're happy with the text mode. So you open the file in a text mode without say anything. Okay. So when you open the file in a text mode, you can, of course, you can read character by character, line by line, right? So when you read 4, we'll read the first 4 characters, read 4, will another the next 4 characters. So basically, there will be a some kind of pointer will keep increasing. Once you read 4, a pointer will increase to your current position. Then you read 4, it will read the next 4, next 4. Or you can read line. For example, you can call read line. It will read the first line, then the pointer will increase. Then you will read the line, it will read another next line, and until you reach the end. Okay. So, but when you say read lines, it will try to read everything remaining there, all the lines remain. Okay, then you close. Yes, questions?
So it's not possible to duplicate what you read in the file?
Sorry, again, one
It's not possible to duplicate what you read in the file?
duplicate.
Like if it's read, it's not going to be read again.
Oh, I think that we didn't talk about that. I'm sure there's a way to rewind to go back to reread. Yeah, but try to find out. Try to do a search and find out. Yeah. Are we fine? Yeah. Also, usually once you read, you can just play with whatever you already hold in your buffer. Yeah, it's better than go back to reload the same content. Yes.
How do we read it like Excel file? We say comma separated.
Yeah, if you have the Excel file, usually I assume Excel file is also very complicated. If you're talking about the how to say Excel, the most time when I play Excel, when I using the actual things to read, I will try to assume the Excel file probably is in like in a comma separate version. Those things that will be text. You will be usually line by line. Then you split your line using a comma. You get a lot of numbers. Yeah. If you are talking about the Microsoft version of Excel, I'm assuming you probably need some kind of specified function to decode the file. Yeah.
What are our read arguments separated by commas?
Sorry?
When we're doing f.read or f.rewind, whichever one it is, how do we actually specify that we want comma separated?
I think that we will talk more when we come to the text processing part. Yeah, we will give examples how to load a file, how to process, split them into tokens. And actually, right after these slides, we were also talking about the regular expression. You will see how those are more advanced text processed method in Python. This is just to give you a basic idea. There's a file concept. You can load file, you can read, and which is like prepare you to enter the next stage. We will have a much more complicated task to handling the text. So just be patient, and we will see more answers. So far, I just hope you are comfortable to say, okay, you can open a file, start to read and write. Yeah. All right, so let's move to this a very exciting topic called regular expression. All right. Without even using regular expression, Python already has a lot of very basic, simple text processing functions. For example, if we have a string called hello world, we can, let's say, count the number of characters in this string, which will return 3. You can check if this string ends with LD, then it will return true. Then you can check if this ELL is in this S, it will return true. And you can say, I will try to find ELL, it will return the index. You can say it will return 1, right? So try to ask yourself why it's 1. And then you can say, I want to replace 0 with, no, sorry, replace O with 0. You can see O will be replaced with 0. You can call, I want to split using this white space. You will get a list. So all those things, another things you can join. Yeah, of course, you can using a string to join the two things. So as you can see, this is already good enough, right? So it's provided quite a lot of useful functions. But today we want to say, okay, how about to handle even more complicated, fancy version? For example, this is one example. I hope this will scare you a little bit to say, I give you a sentence and I want to find all double later that are one character away from the end of the word. So basically that defines the double letter, which is like hello, like a cool, OO, LL. They are one character. They are one character away from the end of this word. All right, how to find that? This is sounds like a very complicated. If you want to write some code to match this, it's troublesome, right? Now I show you a very fancy, scary sentence. I told you this word, do this. Okay, this is what we are trying to tell. What does that mean? So I want to say, this is a pattern we will define to match the double letter, which is one character away from the end of the word. Okay, so I don't expect you to understand anything about this now, unless you know regular expression before. But after this class, I hope you will start to able to appreciate why this is defined this way. Okay, so then after do that, you can simply try to do a substitute function inside S, and then you try to make every match into the uppercase. Then you will get hello. You can see I find not only find those double word, but also make it upscale. Sorry, up cases. All right, so this is a task we are going to do today. So first, let's see some way to define the regular language. So it's a language, a regular language is one class of the language, those defined by regular expressions. And we will use that to find whether a string will match a regular expression, or more formally, whether a substring is in the language. Yeah, we will see more examples. I think that, but this is just give you a very very broad impression about what we are going to use with this regular expression. So first of all, a single string is a regular expression. Yeah, because in order to define what are regular expression, we need to have at least a few minimal rule to claim what is regular expression, right? So first, the first one is a string is a regular expression. For example, ECE20 SM5 data signs, or even empty string, they're all valid regular expression. All right. So then all other regular expression can be built up from three operations. First, concatenating two regular expressions. So if you know this is regular expression, this is regular expression, I just concat them, I will get another regular expression. Okay. Second, a choice between two regular expressions. The choice will use by this bar. You will put a ECE20 SM5 or bar data signs. So this will give you a choice. So basically, you want this or this. Okay, so it's like all logic in between. And then you're repeating a regular expression 0 or more times. This will this star sign will, that means you are repeating a regular expression 0 or more times. So basically, this is a few operations we are used to as our composition rule. Okay, so we get some more basic, let's say some strings, some special character. Then we use these three composition rule to create more fancy or more complicated version of regular expression. Again, we can concatenating different regular expression. we can put a bar in between to create a choice. You want this or this, or you want put a star at the end to try to repeat 0 or more times. But remember, you can see we have a parenthesis here. If you do not have the parenthesis here, okay, the parenthesis here is to create a group. I think later we'll talk about this concept. But if without this parenthesis, it still is a valid regular expression, but that means something else. Okay, can you see why? Because if I remove this parenthesis, what I'm talking about is this guy. If I remove the parenthesis, it was still a valid expression, regular expression, but that means EC, and then you will have a repeated E. All right, you will have 0 or more times of E. Instead of you are repeating the ECE, the who things, right? Because if I have parentheses here, I will mean the ECE. First of all, probably I have 0 times. I have nothing. Or we have 1 times EC, 2 times EC, EC. All right, you get the difference, right? So in Python, how to build regular expression? A regular expression in Python is compiled. So we usually need to not usually we must do import RE to import the regular expression. Okay. And then we can call re.compile. You will try to compile a regular expression and to assign to P. All right. So what we can change is inside here, right? So this it will be the place you can write your own regular expression based on the situations. And then you can use the P to start to do things. For example, match, search are the 2 common operations. So let's take a one step back to look at what this regular expression try to say here. Try to give yourself like 3 seconds to think about what does this regular expression try to say? What patterns it try to match? Right, it try to say there's we are interested in a pattern, or we are specifying a pattern which has ECE, then white space. Then you have one of the 3 choices, either 264, 20x75, 368. Any of these 3 followed after ECE will be the pattern we are interested in. Okay. All right. So now I can ask questions. First, I want to say p.match. This is try to look for a match. Using this regular expression within the string you are provided here. And of course, our pattern is specified as I say EC, then followed by any of those 3 numbers, right? So of course I will find a match here. I will return a match object. I think that later I will showing you more examples in the Jupyter notebook. You will see what it will try to return. It will try to give you the matched string and then starting and ending index. Okay. So then the second example is very interesting. I give you hello EC to the SM5, but when I call a match, it returns none. Why? Because we put this example here to remind you the difference between match and search. Okay, the match is try to look for a match at the beginning of your string. So this is this ECE 264, this match has happened at the beginning of your string. So I can find it. But if this match hidden inside your string, then the match function will return null. Okay, it's only look for from the beginning. So in that case, if you want to find this guy, because this is actually is a pattern we are interested, so you need to do a search. You want to search inside your string until you find the matched pattern. Okay, so this is the difference between match and search. All right. Is that clear? So when you do search, you will return a match string because this is the pattern you are specified here. Yeah, I think the SI we specify match will check only at the beginning of the string, while search will look through, but only return the first occurrence. All right. So now we take a more detailed look at what a match object returned by your search or match operation. Okay, so now let's say we call this, right? Because we know P inside, we have ECE, there's three numbers, any of them will create a match. So because we know we are able to find a match here, okay. So the X supposed to contain your searched result. If we print X, you will get something like this. You will get this is a matched object, and the match find between the index 6 to 13. Okay, the actual matched string will be ECE 368. So I hope you you understand what are those information print out. Okay, because you can count 0, 1, 2, 3, 4, 5, 6. Yeah, so this is a 6, right? So this is a index 6. So 6, and then you count 6, 7, 8 until 13. That indicates this is a index range you capture your matched string. All right, and to see if you are only interested, if you do not care about where are those the span index, you only care about the actual matched string, you can use the x.group parentheses. It will return the matched string. Okay, and you can also call x.span. This will return your 6 and 13. So basically, return all the partial result inside this X. Any questions? Yes. Yeah, I think that, yeah, try to double confirm that and see what is the convention. I think that as long as this 6 and 13 give you information, just remember how it's designed there. Yeah, should be good enough. All right, so now it's a memorization time. So probably we need to do some rote learning. Yeah, there's no other ways. So now let's memorize those things together. If you have a dot, it will match any character. Okay. If you see up arrow, then a string, it will match this string only at the beginning of your string. Okay. Oh, by the way, those are the syntax for when you write regular expression. If you remember at the beginning, I show you a very fancy version of a regular expression, right? I told you this is a pattern. This is a pattern I'm looking for a double letters. one character away from the end. This is I specify a pattern there. But to specify this pattern, I'm using a lot of this very weird. For example, I have a dot here, you can see, right? That means I match anything. So those are the syntax. You have some special symbols in the regular expression to provide you a way to specify things, right? So now this is a definition of those syntax, and we need to really learning them, like memorize them. It will help you to write your own expression. So then you do the ABC dollar. That means it will match the ABC only at end of the string. Okay. So remember up arrow. That means ABC at the beginning of your string. Then dollar is say ABC at end of your string. All right. Then this you can memorize them in group. This A question mark will match 0 or 1 of A. So that means when you put let's say A question mark, that means I want A appeared 0 or 1. Of course, you can put B question mark. That means I want B to appear 0 or 1. Right? So we're just using A, B, C, or A here as examples. You can put anything. Then A star, it will match 0 or more of A's. Right. So when you see A, I put A star. That means for that particular place, I hope to see either I don't see A, or I see A once, or see A twice, and so on. Yeah. So if I see A plus, that means at least I want to see A once, or twice, or 3 times. So the difference between these two guys is one allow the A does not appear at all, but the other require A at least to appear once there. Okay. I hope you all know why those things are required, right? Because this is used to write the expression. Okay. When we use the square bracket and put ABC here, this is try to match A or B or C. This is actually we already see the alternative way to write this, right? You can put also parentheses A bar B bar C. Yeah, so it's a very similar effect to this. But this allow you to do another thing is you can put a square bracket and then put a upper arrow here. Then you do the ABC. That means I do not want ABC. I can match anything, but not ABC. All right. And then you can put a to Z. This is a more simplified version to say it will match any letter between A to Z. This is a much, you can, of course, you can say, you can also put the A dash B to say anything between A to C, anything between A, B, C. Yeah. So yes, questions. Yeah. Of course. Yeah, you can do that. You need to you try to find out that. I think that you can probably you can put a small A to Z and uppercase let's say A to Z. Yeah, those you can. Yeah, I forgot the ASCII the order of those. Yeah, try to yes.
Is that inclusive of A and C?
Yes. Questions? Yes.
Like the last one, A to Z. Is that the first occurrence of one of those, or is it for all of them?
Any of them. Yeah, try to find anything between A and Z. Yeah. Yes.
What does it mean, matches?
Matches is a yeah, very good question. I'm very happy you asked about this. So the reason why we want to, at the first place, why we need a regular expression, is because I give you a string, let's say hello EC20S75. I give you a string. Then I say I want to look for a particular pattern inside this string. then you were using your regular expression to compile a pattern. You can say, I want to look for a pattern which contains, let's say, 2 A's, then followed by 3 times of Z, and followed by some arbitrary pattern. You want to code that, right? In this example, of course, we use a very toy one. We just say we want to look for a pattern which is has ECE, then white space, then followed by any of these 3 numbers. So that it will be the pattern we are looking for. So now, then I give you, let's say, hello, maybe hello, 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 ECE20, SM5. Then I put this pattern. I say, look, go to look for this pattern. Then I will create a match to say, hey, there's a ECE2075, match what you want. Of course, when you specify pattern, it's less likely that pattern will be matched only one thing, right? Because if you match one thing, you will just give me a string, right? So a lot of times you want to say, I'm interested in this. I only care, for example, I only care about ECE, but followed by any numbers, right? Then you probably, if you want to say any numbers, then maybe you can use something, the syntax here. But I haven't finished all the syntax yet. So the next slide will tell you how to use the digits. For example, you will start using /d to denote any digits. Then you probably put a /d, then maybe a star to say a repeated digits. See the tricks here, right? Okay, great. So we haven't finished our memorization. /s will be match white space. /uppercase s will match non-white space. So you see the very cute here. The lowercase means white space, but when you put uppercase, then we say no white space. Okay, it denotes this cannot be a white space at this position. Okay, then the /d will match digits. Then /uppercase d will say I can't have digits at this place. You can have anything else, but not digits. Okay. Then /w is something we very often you will use. This is a kind of alphanumeric. So basically, it's equivalent to say A to Z, uppercase A to Z, 0 to 9 plus a underscore, right? The /w, remember, this is we use it pretty often. It denotes basically the letters and the numbers, then plus underscore. Okay. Then /w, of course, you take the reverse. So I would say maybe the homework is to memorize those. Then we will go to more interesting examples. Just go back to memorize these 2 lists. Otherwise, you will get lost. You will don't know what we are writing about. So I'll stop here. I see you next class.